Okay, Q, you asked about how to do this problem. Let's just go ahead and do it from scratch. So we're going to use the quotient rule. The quotient rule says that if I have a function f of x divided by g of x, and we want to take its derivative, then that equals the derivative of the top times the bottom minus the top times the derivative of the bottom. I got enough room there. All over the bottom 1 squared. Okay, so that's our pattern. And as you noted in your email, we can rewrite this function by changing the square root of x to x to the 1/2, making it easier to do a derivative. And so let's go ahead and do that. So g prime of x, according to the formula, says take that derivative of the top, which is 1/2, x to the negative 1/2, by using the power rule, times the bottom, so x to the 5th plus 3, okay, minus the top, x to the 1/2, times the derivative of the bottom, which is 5x to the 4th, and then all over the bottom squared. Okay, and as I noted in the live webinar, this is that was sort of the easy part. Actually, the hard part is simplifying. So I'm going to try to make this brief, but also clear. I'm going to go ahead and actually write how you would simplify this, and then explain what in the world just happened. So I'm going to go ahead and do this. Since here 2 x to the 1/2 squared over, the eraser just turned on. Nice. Undo that. If I tap my pencil twice, it turns on the eraser, but sometimes it does. Apparently I tap it by accident or something. Okay, so that's the sort of like intermediate step to simplifying, but like where in the world, how did I get from that blue to the red? And so I'm going to go ahead and try to explain that over here in the other, over here, exactly what's going on. So basically I'm taking out the greatest common factor. And what I'm doing here is I'm trying to simplify a little bit by pulling out 1/2 x to the negative 1/2. And why in the world would I choose 1/2? Well, remember that when you take a greatest common factor, so say like if I had a much more simple one, like 5x squared plus 10x. In this case, we would choose our greatest common factor to be the number that goes into both numbers, so 5 goes into both numbers, and the lowest power variable, which is x to the 1, because that's 1. And then we would divide that out. So when I divide this out, I get x, 5x squared divided by 5x, and then 10x divided by 5x is 2. So that's our sort of standard way. But you can use that same exact principle here. If I actually look at the numbers, the number in front of this x to the 1/2 on the second is 1. So what number goes into 1 and 1/2? Well, 1/2 goes into 1/2. It goes into itself, but it also goes into 1. It goes into 1 twice. Okay, and then if you were to pick the least power is negative 1/2. And so if I pick that to be my least power, then I can factor that out. And so if I do that, and let me go back here to the brown I was using earlier. If I do that, if I pull that out of this top expression, and I'm going to start messing around here with the, if I do that, this part actually just goes away out of the first section, okay, because that's like a section of multiplication there. So that's just gone. So I'm left with x to the 5th Oh, the eraser just turned back on again. X to the 5th plus 3. Okay, but if I pull it out of this section, if I divide, so basically what I'm saying is what happens if I take, and we're going to ignore the negative because the negative is just going to stay there. So if I just take 1x to the 1/2, just x to the 1/2, and I divide it by 1/2 x to the negative 1/2. Well, the easier part is what happens with the x, because I subtract those exponents. So I take the top exponent 1/2, and I subtract the bottom, which is negative 1/2, which means I add them. And 1/2 plus 1/2 is 1, which means that what happens when I do this, I'm just left with x. Now the other part is what happens when I take, basically this is a 1 up top, 1 divided by 1/2. In other words, how many times does 1/2 go into 1? And that would be 2. The other way you can think of it is that when you divide by a fraction, so when you divide by 1/2, you multiply by its reciprocal, and the reciprocal of 1/2 is 2. So when I multiply by 2, I get that. But then, so that's what happens when I divide this part, but this is still here, so I have to, still have that 5x to the 4th. And so this right here is how I got, if I can sort of try to highlight this section, you can see this section showing up. Apparently I don't have enough parentheses here. There's a small one. You can see that section show up right here in the top. So then the question is then where in the world did this go? Well, this is multiplication. So if I have division on the top of the numerator, so I'm dividing by 2. Well, what is division other than putting it in the bottom? So instead of having this 2 here, I put it in the bottom. And the other thing is that this negative 1/2 power, well, that means division too. Negative powers means division. So I can also put it in the bottom. So that's why the 2 went down here and the x to the 1/2. Okay, so it's a long walk for sure, but that's how you get to that stage. And then once that's the hard work. If you can get that, getting to the final part of the answer is much simpler. If I multiply these two pieces together, I get minus 10x to the 5th. And then I just take the x to the 5th and subtract 10x to the 5th and get minus 9x to the 5th plus 3 in the top. And in the bottom, I have 2x to the 1/2. Or if I wanted to go back to the format that the question started with, 2 root x. I'm not going to worry in the final which way you go, but I'm trying to be more proper for the video here. And there you go. Okay, so it's difficult. The difficult step is going from oh, that was weird when that just went away. The difficult step is the one going from this dark blue to the red. You've got to use some greatest common factor techniques that use the same principle as greatest common factor, but in just a weird way. And then realizing that when you have division in the top of the fraction, you can just put it in the bottom of a fraction, the division part, because that's what it's doing. Okay, hopefully that all made sense and helps you out on the final.